Some engineers in the tech industry earn around $120,000. Others earn over $200,000. And surprisingly, the difference is often not experience. It is the role. Two engineers can work at the same company, write code every day, and still end up in completely different salary tiers. The reason is leverage. Some roles influence a small part of the product. Others influence the entire system. And companies pay very differently for those two kinds of work. So the real question is not simply how to get a job in tech. The real question is which roles still create the kind of leverage that leads to higher salaries. Now, salary breakdown. In the United States technology industry, many engineers begin their careers between $110,000 and $140,000. Engineers with several years of experience often move into the range between $150,000 and $190,000. But the highest compensation levels, often between $200,000 and $240,000, tend to concentrate in roles that influence infrastructure, architecture, or system reliability. These engineers are not just building features, they are shaping how the entire system operates. That level of responsibility creates far more leverage for the company, and leverage tends to drive salary. Now, market demand. Demand for engineers working close to infrastructure and system architecture remains relatively stable compared to many other areas of development. Modern technology companies operate complex distributed systems serving millions of users. These systems must remain scalable, reliable, and secure. As products grow, the underlying systems become harder to maintain. Companies therefore continue to invest in engineers who understand system architecture, platform engineering, and operational reliability. Instead of expanding product teams indefinitely, many organizations now prioritize the engineers who maintain the foundation of their technology stack. Now, competition level. In practice, this means the tech job market is not equally competitive everywhere. Some roles attract thousands of applicants for every opening. Other roles struggle to find engineers with the right experience. Infrastructure engineering, distributed systems, reliability engineering, and platform architecture often require deeper knowledge of how large systems behave. Because fewer engineers specialize in those areas, companies often compete more aggressively for experienced candidates. This imbalance is one reason why salaries can diverge so dramatically between different engineering paths. Competition across the technology industry has increased significantly. The previous decade saw massive growth in software development careers. Thousands of engineers entered the field, particularly in application and product development. At the same time, modern frameworks and tools allow smaller teams to build complex systems. This means companies hire more selectively. Engineers who specialize only in application features often face more competition than those who understand distributed systems, infrastructure, and platform architecture. In other words, the competition exists everywhere, but it concentrates in certain parts of the stack. Now, junior reality. Most engineers begin their careers close to product development. They work on features, user interfaces, or application logic. This is the fastest way to gain experience and begin shipping code. However, engineers who gradually move toward infrastructure, reliability engineering, or system architecture often gain access to higher leverage responsibilities. Those responsibilities influence how entire systems operate, and engineers working closer to those systems tend to gain more visibility inside their organizations. That visibility often translates into faster salary growth over time. Now, long-term outlook. The long-term outlook for infrastructure and platform engineering remains relatively strong. Software systems continue to grow in scale and complexity. Companies depend on stable platforms, reliable architecture, and scalable infrastructure. Cloud computing, distributed systems, and platform engineering will remain central parts of the technology industry. Engineers who understand how systems behave under scale and operational stress will continue to be valuable even as tools evolve. Now, positioning strategy. Many engineers eventually realize that their career progression is less about writing more code and more about understanding larger systems. Engineers who understand how services communicate, how data moves through systems, and how infrastructure scales under load tend to become more valuable over time. These engineers often become the people others rely on when systems fail or when new platforms must be designed. That level of trust inside an organization tends to translate into both responsibility and higher compensation. For engineers thinking about long-term career positioning, the key question becomes leverage. Which roles influence the largest portion of the system? Engineers working close to infrastructure, platform engineering, reliability, and architecture often influence the work of dozens or even hundreds of other engineers. Working closer to the technical core of a system increases both responsibility and compensation. Understanding where that leverage exists can help guide career decisions. Now, risk and resilience. No role in the technology industry is completely immune to economic cycles. Hiring slows, companies restructure, some technologies become obsolete. But engineers who understand fundamental system behavior tend to adapt more easily across companies and industries. Knowledge of networking, distributed systems, infrastructure design, and system reliability remains transferable. That adaptability becomes a form of career resilience. Now, final verdict. High salaries in technology rarely come from coding alone. They usually come from where an engineer sits inside the system. Roles that influence infrastructure, reliability, and platform architecture create leverage across entire organizations. And leverage is what most often drives the highest salaries in modern tech careers.